Cool. Hey everyone, I'm Noah. I'm an iOS engineer at PlanGrid, and today I'm going to talk a little bit about CoreImage for fun and profit. So if you happen to follow me on Twitter, you might have seen for the last 4 or 5 months that I've kind of been tweeting this random stuff about CoreImage and CI filter fun facts. The reason for that is that about 4 months ago, I kind of went into this like curiosity rabbit hole about CoreImage and how I can, use it in Swift and figure out how to use it most effectively. And the reason that started was because of PlanGrid. So if you don't know what PlanGrid is, basically we are a construction productivity company. So if you're a contractor who is constructing a building in the field, you're generally going to work off of blueprints, which are these line drawings that have like precise technical specifications about how to build the building. And PlanGrid basically allows you to access and edit all your documents on every platform in the field and collaborate in real time. So you have web platform, Windows, Android, and of course, iOS. And it turns out that one common workflow that people do when they're accessing these blueprints is comparing the different versions of a given blueprint. So in this case, this is a screenshot of the PlanGrid UI. You can see that we've highlighted the things which are in one version of the blueprint in red and the other in blue. And then where the blueprints overlap, aka where they haven't changed, we highlight that in black. So this allows people to go and when they get a new blueprint, see what has actually changed, whether they need to make adjustments, etc. So on iOS, we do this using a pretty complicated CoreImage pipeline. And I was basically sitting at my desk trying to fix a bug about this. And I was reading more about CoreImage and CI filter and everything. And I realized a couple of things. One is that there are a crazy number of powerful image processing filters that are just built into iOS. Any app can use them. As of iOS 12, there's 207 image processing filters built in. But the other thing that I realized is that the documentation for these filters is inaccessible or out of date in a lot of cases. Apple does have a documentation page for CoreImage filters, but it's officially like the document is like deprecated, even though they keep adding new CI filters in every release. And it says that it won't be updated anymore. So lots of times if you're looking at a filter, you have to sort of search Google and find somebody who header dumped the private files to figure out like what filters exist even. So I figured that there had to be a better way, and 4 months later, I kind of came out of the rabbit hole with this website called cifilter.io. And basically, this is a website where you can go online, search through every filter that exists, tells you which platforms is available, descriptions, parameters, and gives you examples of the different filters. And so during this whole process, I learned a lot of stuff. One of the things that I realized is that CoreImage has a lot of things, everything from like really fancy CoreImage processing pipelines all the way to like photo booth selfie filters. So this is kind of like the fun and profit of CoreImage, and I'm going to hope to go into both today. So yeah, just a little bit of an agenda where we'll talk about CI image and CI filter, which are kind of the building blocks of CoreImage. Go through some common and useful filters. I've highlighted a couple of like random gotchas that I wish I knew when I was starting to work with CoreImage. And then I have a demo of applying image filters because everyone loves live coding. So CoreImage, what exactly is it? So Apple describes it as a framework to use built-in or custom filters to process still and video images. So if you break this down a little bit, there's 2 components, right? The first is images, which in CoreImage are represented by the class CIImage. And there's also filters, which are represented by CI filter. We'll talk about both of these. So what is CIImage? If you're just sort of like an iOS developer who mostly programs in UIKit, you might be more familiar with UIImage, which basically encapsulates pixel data that can be drawn in a UI image view. But CIImage is a little bit weirder. Apple actually says in the documentation that it's not an image. So if it's not an image, what is it? It's a recipe for producing images. So if you have a CI image, that doesn't necessarily in itself mean that you have pixel data ready to draw, but it means that you have an abstraction of some way to draw pixel data if you wanted to. So basically, when you instantiate a CI image, generally no pixel data loading actually happens. So it's lazy evaluated by default, which can be a little tricky, and we'll go into sort of the things that you can get hung up on with that later. The other thing that's cool about CoreImage, CIMage, is that pretty much every other framework that has a image data binding, CIMage provides a way to import it. So if you have a CG image, UI image, CV pixel buffer from Core Video, Metal Texture, just random data, you can create a CIMage with that data. So CIMage is kind of this one sort of central point for collecting all your image data, and then you can use that to transform it. And you transform it using CI filters. So CI filter, what exactly is it? Well, it's basically an object which takes inputs and produces an output image. So it accepts 0 or more inputs, and it does it via KVO. You can pass it images, ints, floats, vectors, you name it. And it outputs one output image, which is a CI image. It can be applied to still images just with CI image. There is also a way to, with AV video composition, apply a CI filter to every single frame of a video. So AV video composition has a convenience method for doing this. You can also extract the frames themselves and apply the filter each frame via CI image. So I thought it would be good to give a little bit of a concrete example. This filter is called CI box blur. It basically is a filter that takes as input an image and a radius, and it uses the radius to blur the image. So in this case, we can instantiate CI box blur and pass it via KVO, this input image and input radius, and then it gives us back the output image. This is actually CI box blur being applied with an input radius of 100 pixels. And so how does it look in code? Basically, you apply the image, create the filter, and then get the filter's output image. So one of the things you'll notice about this is it's a little bit of string typing. I think this is kind of due to the fact that CoreImage has existed way before Swift, but it's generally safe to unwrap CI filter objects if you're sure that the given name, like CI box blur, is supported on your platform. You do have to be very careful about the output image, though. It's an optional CI image, and different filters do different things for invalid parameters. So for example, if we pass in -100 here, an invalid parameter, you might either see the output image being nil. For some filters, other filters will throw an exception. Other filters will try to call CI image methods on NSNull. It's pretty kind of a thing where you have to deal with it on a case-by-case basis for error handling. Okay, so now that we've talked a little bit about what CI filter is, let's go through some useful filters. So one thing that I really found very useful when I was learning about CI filters are these compositing operations. So CI source in compositing is basically an AND gate for images. So you can assume that a transparent pixel functions as a 0 and a non-transparent pixel functions as a 1. And basically this does the AND of these two images and produces an image where the content is the input image, but it's only represented where the two images overlapped. CI source out compositing is a little bit of the similar thing, but it's actually a NAND gate, like not AND. We have CI source atop compositing, which just pastes the input image over the background image, but only in the input background images frame. And then source over compositing just puts one on top of the other. So this is very useful for when you want to make a background image and put another image over it. Use CI source over compositing for that. And I put links to documentation here. Another interesting thing that CoreImage has is generators. If you want to generate a data code, QR code, Aztec code, PDF 417 barcode, you can do that. They also have, these are not the only ones, there's also other generators for different data codes in CoreImage. This is pretty cool, just if you want to encode something and do like a QR code, which is fairly common. There's also effects, so if you want to relive your 2007 photo booth days, you can use sepia tone, thermal, CI X-ray, CI comic effect, etc., to just kind of apply effects to images. And these are examples of filters that don't take any parameters at all except for one image, and they just kind of output a stylized image. So that's pretty cool. So I wanted to go through, before we get to the demo, a little bit of sort of gotchas that I wish I had known when I started working with CoreImage. The first one is called extent. So CI image has this property called extent, and it specifies the bounds of the image as a CG rect. And you might be thinking, well, isn't the bounds of an image just 0, 0, and the image's width and height? that is the case for UI image, but for CI image, it's a little bit trickier. CI images can actually have infinite extent. So if you instantiate a CI image with a CI color.red, for example, you're actually getting a recipe to create an infinite image. And this is fine, actually, because we're not rendering it anywhere. So the fact that we're trying to render an infinite image isn't a problem. What does get into a problem is what happens if you set an infinite image onto a UI image view. The answer is UI image view doesn't render anything. And this was really sort of unintuitive for me because I was setting images on my image views and I was like, where is the image? I don't know what's happening. But if the extent is infinite, UI image view won't render it. So the way to get around this is to use cropped. Cropped2 is this method on CI image, which basically crops down the image to a given rectangle. So you could crop down an infinite red image to just one that was 500 by 500 pixels tall, for example. Another gotcha is that UI image has this backing, right? And generally we see in regular like UI kit programming, UI images being backed by CG images. But a UI image can actually be backed by either a CG image or a CI image. So UI image has these properties called CI image and CG image, and these will be nil if the types don't actually back the image. So if you have a UI image backed by CG image, my image.ci image will be nil, and vice versa. So this is a little bit tricky when you have a UI image view rendering a UI image which is backed by a CI image. The tricky thing is that CI images, especially if they're composed of multiple filter applications, can sometimes take a long time to render, like on the order of seconds. And UI image view, when provided with a UI image that is backed by a CI image, will render that image the first time it appears on screen. So this can be an issue if you have an image that's taking a really long time to render, and image view is trying to display it, and it actually will block the main thread while it's rendering. So the way to get around this is that you can use this class called CI context to directly create a CG image. So you just call context.createCGImage, and you pass in a CI image, and then now you have that CG image, which is real image data, and you can pass it to UI image and put it on the image view. The good thing about this is that there's no actual UI kit calls happening until you create the UI image. So you can create a context and render the CI image to a CG image on any background thread that you want. It will work just fine. So that's pretty nice. One other last gotcha is that processing time, you have to be careful about it. For example, this is a application of a filter called CI bokeh blur, which basically uses ring shapes to blur the image. This filter seems fairly simple, but this image for a small image actually took like 8 to 10 seconds to generate. So you can't really depend on CI filters rendering like every frame or something like that. You have to take into account that if you want to render an image, you might have to do it asynchronously, implement loading, etc. All right, so we have a little bit of a demo that I wanted to go into. The exercise that we're going to kind of do with CI filter is we're going to implement this fairly common image operation, which is you have an image with a transparent background, and you want to highlight the fact that it is transparent by putting a checkerboard behind it. So this is pretty common in image processing programs like Photoshop or Sketch. So we're going to learn how to do this with CI filter today. So we can hop into Xcode. Can you guys all see this? Should I make the text larger? Okay. So I put together a little bit of a sample amp for this. It's just a view controller that has an image view, and it displays our image, which we're loading, called Swift, from the image bundle. So we see now that we do have a transparent image, and this is around here is where we want to put the checkerboard. So in order to do that, what we're going to do is kind of a two-step approach. There's a filter called CI checkerboard filter, which, CI checkerboard generator, which we'll use to generate the checkerboard image, and then we'll underlay that on the Swift image. So how we're going to do that, we have to import CoreImage first. It's just declare an extension on CI image. I'm going to call it checkerboarded which will return a new CI image underlaid with the checkerboard, right? And the thing that we have to do now is look up the documentation for CI checkerboard. I think I had it, yeah, here we go. So you can go to cifilter.io. Checkerboard generator is right here. It generates a pattern of squares of alternating colors. So we have to copy the name, and how we instantiate the filter is with a name and parameters. So checkerboard filter should have a name and parameters, and we can just paste that in. And then the parameters, also have to go and look at the documentation. So input center, this generally for this filter is going to be 0. You can offset it to sort of move the, or translate the effect of the checkerboard if you want to. This is a CI vector. So we're just going to create a CI vector. And CI vector can store an arbitrary number of floats, but there's an initializer for xy, which is what checkerboard filter is expecting. So x will be just 0, 0 for now. Input color 0 is one of the colors to draw the checkerboard. We'll do CI color dot white for this. Input color 1, CI color dot gray. And I should note there are these like dot white and dot gray, dot red variables available for CI color. There's not as many as there are on UI color, but we do have white and gray, which will work for our purposes right now. Input sharpness, this is the sharpness of the edges in the pattern. So you can actually make it blurry if you want to as well. So we can just have this be 0 for now. And then the input width is the width of the squares in the pattern. We can just do 20, will probably be okay. We do have to force unwrap this because we might have passed in a string that is not a real filter. And then so just for debugging purposes now, let's not care about underlaying the image, let's just care about outputting the checkerboard image. So we're going to do output image, and so then what we have to do is take our UI image and convert it to a CI image. And there's a ton of initializers. I think it's here, Swift image, and then we can call .checkerboard it on it, right? We can force unwrap this, and then we put it in the image view. And in order to do that, we have to actually convert it back to a UI image, which is a little bit weird. All right, cool. And let's see if we get a checkerboard. Okay, so we actually have no checkerboard, and the reason, I believe, is because I think we're running into the gotcha that I talked about before where the image is infinite. So CI checkerboard generator actually generates like an infinite image. And just to verify that, we can put a breakpoint here before we set it on the image view. And we'll say POCIimage.extent. And we can see that it's like a huge rectangle. And if we call isInfinite, it will return true. So this is an infinite image. So that's the issue. The thing that we want to do, like I said before, is use cropped. So we can actually return .cropped, which returns a CI image itself. And we can crop it to the original size of the image that was called on, aka self. So we do self.extent. And let's try again. And then so just to check, CIimage.extent is now, okay, 500 by 500, great. And we have a checkerboard. It's actually blurry. And the reason I think is because, so values, the smaller the value, the more blurry the pattern. So we actually want to do 1, I think, instead of 0 here. Hopefully we got a checkerboard. All right, great. So now that we got a checkerboard, the next step is to overlay our image, right? So in order to do this, we're going to use another filter which I talked about, which is CI source over compositing. So we'll say let source over compositing filter equals CI filter. And again, you have to go back and find what it's called. So source over compositing, and then we have to pass 2 parameters into this filter, the background image, which will be put below the input image. And one thing that I can actually highlight here is that CoreImage has built-in constants for a lot of these keys. So we can actually use kci image inputs, kci input background image key, and it will, in this case, we want it to be the checkerboard filter.output image, and then kci input image key will be self, because we want to overlay self onto the background image. We have to force unwrap the filter, and then so now we want to use the source over compositing filter, its output image, and still crop it in the same way. So let's see what we've got. Cool. All right. Yeah, great. So we were able to use CI filter to do some compositing of images. Hopefully this gives you a little bit of a look into like the sort of things that you can do with CoreImage and CI filter, and the ways in which you can make these sort of image processing pipelines which compose each other and do a bunch of cool stuff. So, yeah, that's all I had. Thank you so much. We can take a few questions as well. Just wanted to call out a couple links. cifilter.io is online. It's open source on GitHub as well. You can tell me what you think about it on Twitter. And if you're interested in coming to work at PlanGrid and working with me on these crazy image pipelines, then plangrid.com/careers. And I'll also be available after to talk about anything. So we can do questions.
Testing. There we go. Yep. Is there any concept of working with vector data in CoreImage, or does everything have to be very explicitly sized, and then you're obviously doing calculations based on like the the Retina device you're on, or like Mac OS or stuff like that?
Yeah. So everything in CoreImage is working on pixels. So there's no concept of points or anything. To your point about device scale, so you do have to do things like generate an image at double the scale. And then put it into an image view to get the actual pixel density. In terms of vector, like scalable vector format, sort of graphics, nothing built into CoreImage for that I know of. You can write custom CI image kernels though. So if you wanted to, for example, take in like SVG data and try to render it in a specific rectangle, you could write a filter to do that.
Question about the deprecation. You
Yes.
said that the documentation marks it as deprecated.
So I should have been more clear.
What is deprecated?
The documentation page itself is deprecated, and so it says this page will no longer be updated, and in fact it hasn't been updated. If you look at the filters that were introduced in iOS 11 and 12, and I want to say 10 as well, I'm not sure, but there's like tens of filters that exist that are just not accessible on that page. And I don't think there's, someone asked a question when I was practicing this talk earlier, is there like, should we be worried about this being entirely deprecated? Should I even learn CI image? I don't think we need to worry about that because they keep adding CI filters in every release of iOS. And if you look at WWDC videos, there's tons of them talking about CI filters every time, so. Yeah, how do you know that they exist? You go on cifilter.io. Yeah, so the actual question is like, how did I generate this list of filters? CI filter actually has a method called like static method CI filter dot like filters in category. You can pass in category nil and get a list of strings for every filter. And if you instantiate a CI filter, you can call like, I think it's called dot properties, and it will give you this dictionary that has all this data about the description and the parameters and stuff. It's just not accessible online.
What's the nature of the new CI filters? Like, what kind of changes are they adding?
It really depends. So I talked about CI bokeh blur that was added in iOS 11. So they're really adding everything from like blurs to super intricate things. So CI depth blur effect is also iOS 11. And that was due to the fact that the new iOS devices had depth capture. So you can actually input a depth image and a regular image, and it will blur progressively, like kind of akin to portrait mode. There's a whole WWDC talk on this filter. They spent an hour just talking about how to use this filter. So,
and also, like, how large are CI images compared to the like UI image?
how large?
Yeah, since you call them like recipes for actual like rendered.
Yeah, so I'm not completely sure about the actual structure of like the internals of like what you're actually allocating when you instantiate a CI filter. The only thing I really know is it works with a combination of transforms and different kernels being applied, and it sort of knows how to apply them. Generally, the kernel is going to store like the OpenGL shading language text. So I think that generally it'll be very small compared to UI image. Don't quote me on it, but you know, kernel source compared to image data is usually much smaller.
Great, thank you.
Thanks, everyone.